All right, ladies and gentlemen, today we're going to be going over solutions and a lot of different vocab and words, terminology that goes with solutions. So what is a solution? It is a homogeneous mixture. I'm sure you guys have heard that before. We'll go over what it means exactly. So homogeneous just means it's a substance that is the same throughout, and mixture is a physical combination of two or more substances. So solutions are made up of those two parts. The two substances are a solute and a solvent. Those are the two main parts of a solution. What is a solute? Solute is the substance that is dissolved, and solvent is the substance that the solute is dissolved into. So we have saturation as our next term. So what is saturation? It is a measure of the amount of solute in a solvent. Now we can have three different levels of saturation. So we can have unsaturated. So it's a solution that has less solute than the solvent can hold. We can have saturated solution. So it's a solution that has all the solutes that the solvent can hold. And we have a supersaturated solution. So supersaturated solution is a solution that has more solute than the solvent can hold. So it's overly saturated, it's supersaturated. So we have a couple more terms here. So miscible. A miscible solution are two liquids that dissolve into each other. We have an aqueous solution. So an aqueous solution, we saw that real briefly when we were doing stoichiometry. That's a solution where water is the solvent. That's the abbreviation AQ is aqueous. So that has water as the solvent. We have a tincture solution. So that is a solution where alcohol is the solvent. And then we also have an alloy. And that is when we have a metal solution. So we also have solubility. So this is the measure of how much solute will dissolve into a solvent. So this is where we find where we have unsaturated, saturated, or supersaturated is a measure of the solubility. So we have a couple factors that are going to affect solubility. We actually have four. So we have temperature, stirring, particle size, and pressure. Now, temperature can either increase or decrease the solubility, the amount of solute in solvent, depending on what our solution is. We'll talk about that in just a second. So we also have stirring. So stirring causes more particle collisions in the solution. So it's going to increase that solubility. Particle size, we have smaller particles will dissolve faster in solution. And we have pressure. So it affects only gases. So as higher pressure increases solubility. So as the pressure goes up, it increases the solubility for gases only. So when we talked about temperature, we talked about how it can either increase or decrease. That depends on what kind of solution we have. So we have solids and liquids, and we have gases. So for solids and liquids, we have as temperature goes up, solubility is going to go up. For gases, as temperature goes up, solubility is going to go down. So we see that. So there's a difference between those guys. So we have some common rules with solutions as well. So we have like dissolves like. So things that are like each other will dissolve things that are like them. We also have polar solvents dissolve polar solutes. So this is where like dissolves like comes in. So if you have a polar solvent, you can use a polar solute into that solvent to dissolve it. We have nonpolar solvents dissolve nonpolar solutes, so kind of the opposite of that one. So it's still like dissolves like. And then we have water is our universal solvent. That is all we have for that. We'll talk more in class. Have a good day.